Welcome to our business track of the Data Science Salon YouTube channel. This is a presentation by Katerina, Iliakopoulou, lead software engineer at New York Times, where she speaks about how at the Times their use of machine learning doesn't stop at creating the best experiences for their users. It expands to how they serve their newsroom. Katerina shares how they leverage NLP and ML modeling to extract insights and patterns from publishing data to help editors and journalists make smart decisions when promoting NYT content. Enjoy!
Hi, my name is Katerina Iliakopoulou and I'm a lead software engineer at the New York Times. Today we will discuss how we've developed intelligent tools for the New York Times newsroom with my team. So my team is called the Audience Product Group, and it's a group that works really closely with the newsroom. It's a cross-functional team, and it's comprised of developers, product managers, and newsroom people, newsroom editors. And our main focus is to optimize the presence of the New York Times in third-party platforms. Now, this can be done in different ways. One way is to optimize our apps, both mobile and web, so that our content is indexed correctly by search engines and so that people can easily share our content on social media platforms or in general third-party platforms. Same goes for how our content is discovered by third-party platforms. And we also build integrations with third-party tools. For example, most recently, we launched a Slack New York Times app where users can, on different Slack workspaces, can download it and read New York Times articles and save their articles in the Slack workspace. And last but not least, our team also builds customized tools for the newsroom. Now, these tools, the main goal of these tools is to amplify our newsroom editors' judgment in curating and promoting content. And the way we do that is that we collect different types of data from different types of sources. Some of them could be internal to the Times, and some could be data provided by vendor tools, such as how we rank on Google search. And we collect all these different data and we surface them in the customized newsroom tools. The other capability that we provide through these tools is machine learning models that we trained on all these different types of data. And these models essentially provide a recommended action to our users, to the newsroom editors, as to how they should act on the data, what's the best thing to do to optimize and promote our content. And even though our team is focused on quick and fast experimentation, we really care about shipping new solutions fast and getting feedback from our newsroom partners. We also think about scale. So we want to, when we ship a new solution, a new feature to our systems, that it's easy to plug in new data points and that we can iterate on the models continuously and evaluate them and understand whether they're doing actually a good job for what they're set out to do. So one of the main features, one of the main things that we quickly identified as a strong signal for the models that we build and for the data that we provide to our newsroom is the ability to make association in the content that we published. And in some applications related to user experience, this is very straightforward, and we can see right away why making association in published content is important. For example, when it comes to content recommendations for our readers, or if we want to find similar content through search in our apps, it's important to be able to find similar articles to a specific topic or to a similar article. However, it's equally important to be able to provide that signal to the tooling that we provide to our newsroom partners, because this allowed them to understand how we're covering certain topics, how we compare with competitors. Are we missing a key point in our coverage? Are we Are we perhaps covering a certain angle, but we're missing on another? It also provides context on how we are promoting content and how we curate our content on our apps. And as we optimize that, one key feature that was really prominent and allowed for optimization was the way that we backlink to our content. And backlinking is strongly related to how we draw association in the content that we publish. So many of you might be already familiar with what backlinks are, but for those of you who are not, I will provide a quick overview. Essentially, backlinks are the hyperlinks that we add to the article's body, and typically it happens from older articles where we link a certain keyword or group of keywords within the article body, and we link from that these keywords to a newer article. Now this the action of backlinking doesn't only help our readers to navigate through a storyline, because as they read older content, they can easily go navigate to newer content. But it also adds a lot of authority to a story on a specific topic, and it's a great signal for search engine optimization. For example, Google values that very highly, how content in a website links to other internal articles within the same website, or how it also links to external sources. But for our purposes here, we care just about our content. So linking similar stories together actually improves the authority of a story on that particular topic. And lastly, the link text that we use, and also the number of backlinks and the age of the link itself, matter a lot to the quality of the backlinking. Now, the newsroom's workflow at the New York Times when it comes to backlinking typically involve an SEO editor performing a Google site search on the topic. For example, if they want to understand, like, what is the content that we've published recently on the COVID vaccine, they will do a Google site search on that, and then they will see all the results that are returned from Google, and scan the results and find which are those that rank higher. The reason why they don't do an internal search within our apps, within our systems, is because they do care about that signal from Google. They do want to know what Google deems as the most authoritative stories published by the Times on that topic. And that's why they do the Google search. So after they pull up the most pertinent ranking results, they scan through the article body, and they locate a linking opportunity for the newer article. And once they find the context, the text within the body that they can link from to the newer article, they go into our custom CMS, they add that keyword link, they update the article, and they hit republish. And this cycle is repeated until we hit a desired number of backlinks for that topic, which sends a strong signal to search engines, and they will rank as a result that article higher for that particular topic. But as you can probably imagine, this whole workflow, this whole process is very time-consuming, cumbersome, and finding relevant content is not always the easiest thing to do. So as I said previously, one of the things that our team is doing for the newsroom is to build custom tooling that allows them to view different types of data and understand making connections across different types of data. So one source of data is how users engage with our content. Another source of data is data from vendors, which shows how our content performs on social media or search engines. And thirdly is the data related to publication. So and all the content that we've published and all the related metadata to them. So in order to assist with their workflow when it comes to backlinks, backlinking, our team created this topic modeling component, this topic modeling service, which essentially processes all the data or the publication data within a period of time, and trains a topic modeling, and using a topic modeling algorithm trains different types of models that which then are made available to the Newsroom tool to use to get similar content for a specific story. And this similar content will then be used as backlink suggestions to our editors, who can, in an effort to quickly surface good candidates for backlinking. So I'm going to take a step back here and discuss a little bit what topic modeling is. So a topic model is a type of statistical model for discovering the abstract topics that occur in a collection of documents. Now, what that means in the New York Times context is what kind of themes can we find, what kind of topics, range of topics can we detect by analyzing a collection of articles that we've published within a period of time. And that period of time could be the last 7 days, all the articles that we've published in the last 7 days, or all the articles that we've published in the last year, or maybe in the last 3 months. We can also segment the data in other different ways based on what our newsroom deems as relevant. For example, we could say we want to train a model, a topic modeling. We want to create a topic model that detects topics from a data set that consists of articles that were published in the last month and have been published in the politics desk. So that will be very specific for politics. And so the algorithm that we decided to use is the LDA algorithm, which is a quite popular algorithm in the NLP space, the natural language processing space. The full name is latent Dirichlet allocation, and it was published by Bly and G and Jordan in 2003. So the model pipeline for LDA consists of 4 main steps, 4 main components, and it's quite similar to other machine learning pipelines. The first step is the data pre-process. The second step is training the model. The third step is to assign a topic to a document in our cluster of documents. In our set of documents, which is essentially clustering our documents to different groups. Each group is a different topic. And lastly is how we evaluate our model to understand whether it's doing actually a good job finding topics and assigning topics to documents. So the first step, as we said, is the pre-process step, the data pre-process. Now, I talked about how we create different data sets by retrieving different sets of articles from different periods of time or from different desks. So once we have this group of articles that we've published, we extract the main textual components from that article, in which case, in our case, it is the headline, the summary, the body of the article, and what we call times tags. Times tags are specific tags that New York Times editors New York Times editors assign to an article when it's published and indicate what the main entities that are referenced in the article or the subject, what the article talks about. And so we concatenate all of these together, and this is essentially the entry for that article in our data set. And then after that, we process the text of that article by removing any stop words or, in general, words that we deem have little semantic value. We count, like this could be terms that we can see throughout different documents that repeat all the time, or maybe they don't, they are very infrequent, so they're probably not, they're not indicating the subject, a specific subject or topic. We also create n-grams from the text to capture the context. The context of the article, context in the article, and we also perform lemmatization. And then finally, we create a 2D vector. As you can see here, one dimension is the documents, the other dimension is words. And we use TF-IDF to create the different vectors of the words for a document. And TF-IDF is another popular algorithm that that essentially surfaces the important words for that capture the meaning of that document. So this 2D vector is going to be the input of to our model. So as we said, like, we are using an LDA model, and I'm not going to get into so much into the specifics of how this model works. You can read the paper if you're interested for more information, but essentially, the basic idea here is that documents are represented as random mixtures of latent topics. That means that we don't know the topics in advance. And each topic is characterized by a distribution over words. So we don't know the topics in advance. This is what we are trying to find by training the LDA model. But we do have to provide the number of topics that we are trying to find in the data set that we give to the model. So K in our example here is the number of topics. And as you can see here in the graphs, we have two plates. The inner plate essentially represents the distribution of words for a topic. And the distribution here is defined by the beta parameter. And then the outer plate is representing the document plate, is basically the distribution of topics for a document, and this distribution is defined by the alpha parameter. Now, the way we define these parameters and hence the distribution is by running an expectation maximization algorithm that uses as a prior and as a posterior distribution the Dirichlet distribution. And we use the LDA model uses Dirichlet because it's a generalization of the beta distribution for multiple dimensions. Dimensions here being the different topics, the number of topics. So at the end, after we train our model, the output is essentially a 2D vector. One dimension is the words, the other dimension is the topics, and essentially each topic here has a distribution of words that tell us what this topic is about. So if the topic is, for example, about the COVID vaccine, these words COVID and vaccine are probably going to have a very high frequency in this for that topic. So when we are assigning a topic to an article, what happens is that we give the article as the input to our model. We vectorize the article. We get the vector of words for that article, and we then look at that 2D array, and we're trying to find which topic is closer to the vector representation of our article here. And the topic that's closer is the topic that we are finally assigning that article to. Now, what I've said is probably going to be a little bit more clear through this slide here. If we assume that we have, let's say, 3 topics that we are trying to find, like the LDA space could be represented by a triangle. I have made an assumption here that the 3 topics that we're able to detect in our data set are Biden, vaccine, and virus, as you can see on the different corners of that triangle, and the dots inside the triangle are the different documents that we are that the model is clustering, is trying to assign topics to. So as you can see, this example, Biden seeks to use infrastructure plan to address racial inequalities article. It's an article about Biden, so it's going to be closer to the Biden topic in the triangle. However, an article about vaccine passports is going to be closer to the vaccine dimension, that topic. However, because it is about politics, it could be also somewhat related to the Biden topic, and that's why it's a little bit closer to Biden, to the Biden dimension. Now, a good way to evaluate our model is using perplexity. Perplexity is a good metric to understand how predictable our model is. Perplexity is essentially the exponentiation of entropy, and entropy shows us what's the amount of information that our model holds. So the lower the entropy, or hence the lower the perplexity, it means that our model is more likely to predict the same output given the same input. And this is essentially what we want. We don't want randomness. We don't want surprises. We want our model to consistently making the same prediction given an input. And so when we evaluate our models, we are looking for smaller perplexity to say that this model is actually a good model and is doing a good job finding topics within the data set. So going back to the original diagram that I showed you earlier, to recap of all the steps, the LDA pipeline steps that I showed you just now, essentially this red box represents this whole pipeline. It starts with getting a data set from the publishing data that we have, extracting the group of documents that we want to train a model with, pre-processes that data, and then trains the model, and then finally it ships the model and makes it available for the Newsroom tool to query. Again, the different types of models represent different models that have been trained on different data sets. So each model is going to be able to give us a different type of information based on the data set that it was trained on. Really quickly, I want to refer to the cloud-based model architecture of how this actually happens in practice. We use a Google Cloud platform to ship our systems, and so for this we use the Google AI platform to train our models. Our models are trained through Google AI platform jobs, and this happens on a schedule using Kubernetes cron jobs, and then each job outputs the information of the model to Google Cloud Storage, and also it ships the model at the end of the training job on Google AI platform, and then that model is exposed, is made available to our front end service, which is the Newsroom tool that the editors in the Newsroom use to query and get the information that it needs. And this architecture allows us to train multiple models, ship a new model really fast and easy, split our data set in whatever way and using whatever dimensions that we want, and also evaluate it really fast and understand whether it's doing a good job or not. The most recent example that I can give you where we had where the Newsroom used this capability that I just showed you with backlinking, and it had a huge impact, was the 2020 elections. Basically, we have a lot of different ways that we are trying to leverage in order to dominate, let's say, the space on third-party platforms. Among them is one very prominent one is Google Search. So a way to do that is to create live assets, because that means that you're constantly providing new information. But the other way is to also backlink to these live assets from other articles that we're publishing. And so the fact that we provide this capability of an easy way to backlink from stories to newer stories to our editors allowed them to do this process much faster and much more efficiently. And the result was that we basically dominated the Google search across the elections. It was the first time that we won among our competitors, and we had a lot of visibility and a lot of visitors coming in to the site and for election content. So next steps for our team is to explore other types of models. Backlink is one capability that we worked on, but we're also looking at adding more capability related to other functions in the editor's workflow. One type of model that we're really interested in exploring is word-to-vec and also doc-to-vec models. Finding the embeddings from our training neural networks on our content. We believe that it's going to give us a lot more flexibility in the capabilities we provide and in the patterns that we're able to find. We're also very interested in combining that editorial judgment of our editors with algorithms, and basically capturing it in our models. We can see that there are a lot of nuances when they are doing certain things that it would be great if we can capture that in modeling. And also we want to train a lot more models on different data sets and compare them and find interesting patterns. So before I close, I just want to give a shout out to my team, without whom this work wouldn't have been possible. Thank you so much all for coming, and feel free to contact me for more questions in case there are any. Thank you.
That was a presentation by Katerina Iliakopoulou, lead software engineer at the New York Times, who shared how the Times leverages NLP and ML modeling to gather insights and patterns from publishing data to help their editors and journalists to make better decisions when promoting New York Times content. If you enjoyed this video, please subscribe below. Thanks!